In Part 5 of Lecture 6, we will discuss constructing an LR0 parse table. Let's put the parse table together. State 0 is a non-final state. All the dots are before the end of their respective item. That means the action is shift. If you follow the arrows, you will see that we will transition to states 4 and 5 on plus and minus respectively. We will transition on ID and constant to states 6 and 7 respectively. There is no transition on the end of file marker because it doesn't appear immediately before the dot anywhere in state 0. Similarly, we will transition on E, T, and F to states 1, 2, and 3 respectively. State 1 has only two items, both non-final. On plus we transition to state 8, and on the end of file marker we transition to state 12. And obviously the action again will be shift. State 2 has only one item. The final item, E derives T dot. This means we will reduce by production 3. Expression derives term. State 3 has only one item. The final item, T derives F dot. This means we will reduce by production 6. Term derives factor. State 4 has three non-final items. T derives plus dot F, F derives dot ID, F derives dot constant. Therefore, the action is shift. There will be a different transition for each item. If the look-ahead is ID, we will go to state 6. If the look-ahead is const, we will go to state 7. If it is F, we will go to state 9. State 5 has three non-final items. T derives minus dot F, F derives dot ID, F derives dot constant. Therefore, the action is shift. There will be a different transition for each item. If it is F, we will go to state 11. If the look-ahead is ID, we will go to state 6. If the look-ahead is constant, we will go to state 7. State 6 has one final item. F derives ID dot. Therefore, the action is reduce by production 7. State 7 has one final item. F derives const dot. Therefore, the action is reduce by production 8. State 8 has 6 non-final items. E derives E plus dot T, T derives dot plus F, T derives dot minus F, T derives dot F, F derives dot ID, F derives dot const. Therefore, the action is shift. We will transition on plus and minus to states 4 and 5 respectively. We will transition on ID and const to states 6 and 7 respectively. And on T and F, we will transition to states 10 and 3 respectively. State 9 has one final item. T derives plus F dot. Therefore, the action is reduce by production 4. State 10 has one final item. E derives E plus T dot. Therefore, the action is reduce by production 2. State 11 has one final item. T derives minus F dot. Therefore, the action is reduce by production 5. State 12 has the ultimate final item. S derives E dollar dot. Therefore, the action is accept, and we have finished parsing. Now that we have the parse table, we need the parser driver to use the parse table and parse our program. We will repeat the following steps. If the action is shift, we will shift the current token on the stack together with the new state. Reduce by production n. We will pop all the variables of the right sentential form for that production together with their states. We will now push the non-terminal from the left side of the production together with goto of the state and non-terminal. If the action is accept, we'll do whatever cleanup and from then we'll move on. If it's error, we will call whatever error handling procedure we may be using. And we will repeat this until the action for the current state and the token is accept.